Okay, this is section 7.1. We're going to be solving linear systems by graphing. When we finish, I want you to be able to determine the solution to a linear system by graphing each line on one coordinate plane. Now the first thing we have to do is we need to go over the steps. The first thing you need to do is you need to be able to put both equations in slope-intercept form if they're not already, so that you can graph them. Then graph the first equation, then graph the second equation on the same coordinate plane, and then the solution is going to be where the two lines meet. The last thing you need to do is you need to check the solution in both equations. Okay, now let's take a look at this one. Solve the system by graphing. So I have x plus y is equal to -2 and 2x minus 3y is equal to -9. So I'm going to go down here where I have a little more room. My first thing I need to do is to get y by itself. So I'm going to subtract x from both sides, put it in slope-intercept form, and I'm going to be graphing this one in blue. So now I have y is equal to -x minus 2. So now that I'm in slope-intercept form, I know that my y-intercept is equal to -2, and I know my slope is the coefficient of x. So I know this one has a slope of -1. I'm just going to put it over 1. Now let's graph this one first. So I'm going to go to the origin. I'm going to go down 2 on the y-axis. There's 1 point. My slope is down 1 over 1. There's my second point. And I'm going to try my best to use my straight edge and graph this just as good as I can. Now notice when I did this didn't turn out that great. Okay, now let's try the green one. Again, I need to put it in slope-intercept form. So this time I'm going to subtract 2x from both sides. Now 9 and minus 2x, those aren't like terms, so I'm going to have -3y is equal to -2x minus 9. I need to get y by itself, so I'm going to divide each and every term by -3. Now when I do that, I have y is equal to, a negative over a negative is a positive 2/3. X, -9 divided by -3 gives me a positive 3. So this one has a y-intercept of positive 3 and a slope of 2 over 3. Now remember, slope is rise over run. So I have a y-intercept of positive 3, so go to 3 on the y-axis. Then I'm going to go up 2 over 3. Now I am going to try and, graph this as good as I can. Okay, now when I'm looking at this, I'm like, ooh, that doesn't line up very nicely. That's going to be hard for me to guess. I'm thinking I probably made a mistake with my graph, and my graph just isn't precise enough. So what I'm going to do is I'm going to use this pink, and I'm going to use my slope. My slope for the green was 2 over 3. So if I go -2, -3, I have this point right there. Now I'm going to use the purple, my blue. My blue was -1 over positive 1. So if I go positive, then negative, positive, then negative, positive, then negative, I'm going to have a point right there. So I can use my point, my slope, to get extra points for me to look at. So it looks like if I had drawn my graph more precisely, the coordinates would have been 1, 2, 3, -3, positive 1. So let's check and see if -3, positive 1 is a solution. So I'm going to check it in both equations. So I'm going to start with x plus y is equal to negative 2. So negative 3 is my x value, plus 1. I'm going to see if that's equal to negative 2. Negative 3 plus 1 gives me negative 2. Okay, well that one works. Now I need to check and see if it works for the green equation. So for that one I have 2x minus 3y is equal to negative 9. So now I have 2 times negative 3 minus 3 times 1. I want to see if that's equal to negative 9. So that gives me negative 6 minus 3. Okay, that does give me negative 9. So it is a solution. So the solution for this equation is the point negative 3, positive 1. Okay, now let's solve one more. So the first thing we're going to do is we're going to subtract 6x from both sides. So we have negative 3y is equal to negative 6x minus 15. Divide each and every term by negative 3. So now we have y is equal to positive 2x plus 5. Now I know that my y-intercept is equal to 5, and I know that my slope is equal to 2. So I'm going to go to 5 on the y-axis for my y-intercept. I'm going to rise 2, and I'm going to run 1. Now just to help me get a better point, I'm going to go negative 2, negative 1, because a negative negative is a positive, so that keeps me in line. Now hopefully I can write this carefully enough that I can check my answer. Okay, now let's take a look at the green one. We're going to subtract 2x from both sides. So now we have y is equal to negative 2x minus 3. Now I know that my y-intercept is negative 3. And I know that my slope is equal to negative 2. I'm going to go ahead and just put that over 1 to help me remember to run. So I'm going to go to negative 3 for my y-intercept. Then down 2 over 1. Now if I go up 2 in the positive direction and 1 in the negative direction, and I can go up 2 in the positive direction, 1 in the negative direction, that's just to give me more points using my slope. So now I'm going to connect. And I can see that my answer is probably right around in here somewhere. And I'm just going to have to check and see what's going to work. I think it's probably this little point right here. So I'm going to try the point negative 2, positive 1. And I'm going to see if that works. So with my blue line, I have 6x minus 3y is equal to negative 15, and I want to see if that's true with the points negative 2, positive 1. So I have 6 times negative 2 minus 3 times 1. So that gives me negative 12 minus 3. Okay, that does give me negative 15, so the blue one checks out. So the point negative 2, 1 does lie on the blue line. Oh, look, I just didn't graph very well. I was off on my graph. Now let's check the green one. 2x plus y is equal to negative 3. So I have 2 times negative 2 for my y value, x value, plus 1 for my y. Negative 4 plus 1. Okay, negative 4 plus 1 gives me negative 3. Okay, this one checks out also. So the point -2, +1 is the solution, because I'm looking for the one thing that these two lines have in common, and the only thing that they have in common is this point right here. Okay, the last thing I want you to do is I want you to just think about what you looked at today. Are there any limitations or drawbacks by solving these systems equations by graphing? You know, if there are some limitations or drawbacks, what are they? Did you notice any that we experienced today? And I'll see you in class tomorrow. Have a good night.